So this is going to be like prerequisite session that will cover the concepts that you're gonna know. I'm not sure if we'll be able to cover everything within like 1 hour, but maybe we'll see if we'll be able to cover the most out of it. I'll be a little bit in a hurry just because some of the prerequisites are that you already know of that by the virtue of our curriculum. You just need to keep that in mind. However, if you think that you are not following something, yeah, you can definitely stop me and can ask the questions there. Or yeah, let's see. Or if it's taking a lot of time, then we'll figure out some other ways to make this office hours more efficient. Definitely, you should be knowing about the about what Ethereum is, right? So we know that it is a network of computers. You need to just install the Ethereum node software and you can run it. That makes you a contributor slash participant of the network. If you are staking some ETH, 32 ETH, then then you'll be the validator as well, which means that you will be contributing to the security of the network. There is no censorship from where you can create or where you can participate. You just need an internet connection and you'll be able to do it. What Ethereum can do, of course, it's a censorship resistance. It has commerce guarantees, which means that if the funds which belongs to you will belong to you, it can only be transferred to the other account if you allow, or I mean if you have transferred it to some of the contract which has an ability to operate the funds from your account. For example, approve from, it's an open internet, anybody can interact. You are not bound by the boundaries, so you can control your own assets. It is a peer-to-peer network as well, which means that no middleman. You just can transfer the funds directly to other account. It's not like if you want to buy something on Amazon, you need to pass it through the gateway. You can do a peer-to-peer interaction. There is a global state, which means that it cannot differ. Your balance is not gonna be different if you change the nodes. Of course, they should be fully synced. So it's a database of transactions, right? You need to keep that in mind, which is updated and shared across many computers in the network. Every time a transaction is added, it is packaged in a data structure that we call it a block. And if you just keep on appending it, it becomes a chain of blocks, and that is the reason we call it as the blockchain. And then there are certain nuances to it. For example, who are allowed to add the blocks in Ethereum? Anybody can. So it's a public blockchain. Of course, there are consensus rules set if you want to make any changes to the state, and that comes with cost. Just like in cloud, if you are utilizing the units, the compute units, you will be charged. Your credits are going to get deducted from that, right? And then cryptocurrency is a term which is used to describe many fungible, non-fungible. Sorry, they are just the fungible assets, not the NFTs. Bitcoin was the first cryptocurrency, and it can be used to transfer values between two parties. You don't need to trust any middleman because there is none. It's just a network. If you don't trust the other node, just run your own node and you can interact with your own node. The reason about calling it why cryptocurrency is security of your data and assets are guaranteed by cryptography. You'll be learning more about that in one of our module, where you will be building a wallet. Many of the students here have already built it, so they know what is cryptography and what exactly are the features by which you are securing your data. Most of the blockchains have their own cryptocurrency, and they are also the gas token as well. So in case of Ethereum, it is ETH. I don't need to talk a lot about it. There are a lot of advantages of why would you use Ethereum. It's cheaper, faster, and cross-border payments. If you want to pay your employee who is far away in some countries, which the time zone is itself a lot, which means it's far away, then blockchains are at the rescue. They are generally cheaper and they are more efficient than the banking counterparts were traditional banking. Let me just switch the window a bit. All right. I should be actually sharing like my whole screen so that I don't have to keep on switching. So let me just do that. Okay, cool. So I don't have to do much of switching. Yeah, we're just talking about like all the way from Ethereum. Many of you might have been new today. Some of you might have just joined this boot camp. So I just don't want to get you lost. So yeah, we were talking about like what are the use cases for Ethereum. In the past, it has been used for sending medical aid and a lot of aid during during the situations of economic catastrophes, crackdown, civil liberties, where the residents of Venezuela, Cuba, Afghanistan, Nigeria, Belarus, Ukraine were in the crisis. That's where Ethereum was used for the aid, for transferring the aid to them. On the right hand side, you can see this graph. It is actually showing who were the users of the Ethereum. So in 2010, only investors were there just because Ethereum was doing their ICO. But then after it was up, developers, investors, and a lot of companies got involved here. And right now, if you talk about the ecosystem, you can see investors as well, developers, companies, artists, musician, writer, gamers, refugees. A lot of them are getting benefits out of Ethereum. And of course, these educational institutions like Metana, who are spreading the knowledge of Ethereum, empowering creators. If you're heard of creator economy, empowering gamers, you might have heard of play to earn concept. We are not going to go a bit we are not going to go in depth on that. So far, this statistics keep on updating, but as of now, more than 4,000 projects are built on Ethereum. There are more than 96 million accounts which have got some ETH balance. There are more than 53.3 million smart contracts on Ethereum and increasing. 410 billions of token worth of assets are locked. That's what you can say, and they're calling it as value secured. And there are some number of transactions. It's not showing up, but anyway, it might show you. 3.5 billion dollars worth of earning has been taken place on Ethereum in 2021 alone. So there is no centralized party who runs the Ethereum, right? If you stake 32 node, you will be able to participate in block proposal on Ethereum. You know what smart contracts are. There are a lot of dApps. You can explore it. I'll be sharing everything with you during each of our session, which you will have to review after our class is done. We'll be doing whenever we'll be doing some examples. You just have to sit and just watch me coding, because I'll be really really fast. Unless you have any questions, you can just stop me and ask me. But while I'll be coding, I'll be really fast. The reason being, we'll be giving you the code repository, as well as any helpful material after the end of every office hours. So this was about the energy consumption that Ethereum proof of work had. And when it got transferred to proof of stake, the energy consumption is very minimal, just because now proof of stake is not relying on the hash power. Yeah, it is always good to know about what was proof. It is always good to know about history of Ethereum before the merge and after the merge, and all. And of course, there are a lot of events that have been taken place in Ethereum when Ethereum was proof of work, and some of them are related to re-entrancy hacks as well. Here, I'm not gonna go in this. This is more of a legal side of the things. But the difference between Ethereum and Bitcoin, right? They both let you use digital money without any middleman. And Ethereum is known as blockchain 2.0. Actually, the reason is it is programmable, so you can also build and deploy, and you can send some data as well along with the transactions. so it will used in establishing value without any authority, and that is already powerful, right? Bitcoin is just for the payment, whereas Ethereum is like a marketplace of financial services, games, social networks, apps. There are a lot of DApps already there. Firecaster is one of the example of social networks. All right, and these are some of the you know knowledge testers. So definitely go through it. Not a big reading. And next is we're gonna look into DeFi. This is a very nice article on DeFi. I already have like the links with me, so I'm just going to open it up. I have already shortlisted. It is an umbrella term which we use. So basically, whatever financial services, if you are building a banking contract on Ethereum, it is built on decentralized networks. So we call it as decentralized finance, but it is primarily a financial product. If you are building any financial product on a public blockchain which is decentralized like Ethereum, then you just call it as decentralized finance domain or DeFi. So with the smart contracts, we have also had an office hours where we conducted the workshop of building peer-to-peer lending and borrowing pool, just like banks do. We did Uniswap V2 like DEXs, right? This workshop which we are starting today, we are going to build or we are going to learn Uniswap V4, which will also cover some of the concepts of Uniswap V3. And if you want to know Uniswap V2, I definitely encourage you go and check out our office hours recording. It is available on my Notion office hours recording page. If you don't have the link of it, you can just Slack me, and I'll share that with you, or I will redirect to you, or else you can just ask to Emit about the same. This is about like why is DeFi important. It's all the theories. If you are in this boot camp, I don't need to convince you about what is the importance of the DeFi. I'm pretty sure you already have done some research before enrolling in this boot camp. So no KYC requirement for opening an account, which is one of the first requirement. In the bank you can just create a wallet, right? What is lending? You can just lend out. The banks are lending out the money to you, which means you are borrowing, right? And then loan. So one of the concept that Ethereum introduced is the flash loan. So flash loan is a loan without any collateral, right? But the only condition is you'll have to repay it within one transaction itself. One of the use case that people do with flash loans is arbitrage bots. If they see there is an arbitrage opportunity, they are going to make a flash loan from P2P lending borrowing protocol, do some arbitrage and then repay it. You need to create a very robust and very fast bot infrastructure. You need to have your own node, so that you don't miss the opportunity. Not only that, you'll also have to interact with flash bots, right? So it's like a private transaction. You can also buy derivatives, so we call it as perpetuals in DeFi. Transaction rates on Ethereum blockchain, fluctuating, right? So if you are trading continuously, it is going to get expensive, and depending on which dApps you use and how you use them, your investment could experience high volatility. And of course, if you are doing any DeFi related transactions, you'll have to maintain the records for tax purposes. Anyway, this is not any legal or financial advice that I'm rolling out. And this is also one of the good article. Of course, there are a lot of books, there are a lot of blogs that you will be finding, but we are just going to read those material which are good enough for us to start understanding Uniswap V4 and building on top of Uniswap V4. So how you build in DeFi is using the smart contracts. So MakerDAO was the first one who built one of the first DeFi app, and they created the DeFi app for printing the stable coins. The stable coins are backed by ETH. So if you have got ETH, this MakerDAO is going to read the value of US dollar from the oracle, and it will mint equivalent amount of DAI. Mostly not. It will not mint. It will not get you 100% of the value of ETH, but 75% value of ETH will be, landed to you in the form of DAI, right? And they have got ETH as collateral, and then they had a maker token. So it is used in order to make sure that the system has enough backing of ETH. Because what happens if if the health factor of the system fluctuates a bit, then it needs more ETH to back it up. So they are going to either liquidate the current positions of the collateral depositors, or they are going to use their DAO to sell out MKR tokens and get ETH back into the system, right? Another protocol is Compound. Compound and Aave, they are both, peer-to-peer lending protocol. And if you talk about Compound, it is an algorithmic autonomous interest rate protocol. We also did we also did a series of office hours of regarding the peer-to-peer lending borrowing protocol, which is similar to Compound. So you can also take a look into that. And Aave is also one of them. And then we have got algorithmic stable coin, which we talked in terms of MakerDAO. USDC is not algorithmic. USDT is also not algorithmic. The reason being they are all having, backup of real US dollar in the banks. Decentralized exchanges, we know, you can just, do peer to peer. You can just do an exchange based on constant product of or constant sum formula. We're going to talk that as well. Uniswap, Kyber, Balancer, Bancor, Loopring, which are the examples of order book based. Loopring and IDEX are order book based. When it comes to exchanges, if you are familiar with traditional finance, they are all order book based. But Uniswap, Kyber, Balancer, Bancor, they are all automated market makers based on constant product or constant sum. The office hours that we did on Uniswap V2, they are all based on constant product formula. So derivatives derive the value from their performance of underlying asset, and synthetics is an application which is based on derivative. So it provides on-chain exposure to different assets. Margin trading is the practice of using borrowed funds to increase a position in certain assets. DYDX and Fulcrum are the example of margin trading. DeFi also includes insurance. Oracle, Chainlink is one of the biggest player, or maybe they are the pioneer in this space. This is difference between CFI and DeFi, right? So I'll share all these links to you so that you can go over. And this is the fourth one. So these are all the articles which I would just ask you that you just go over it. It's not going to take a lot of your time. If you don't want to watch the videos, I think it's okay, but at least just know some of the financial jargons that are being used if you don't know at once. If you were part of my Uniswap and lending borrowing office hours, think you should know. But if you are not, just go over this page as well if you are feeling lazy to go over my older videos. So basically this talks about how you can get yourself a good hold on decentralized finance. So these guys have um uh, split that into three levels of novice, apprentice, and master. All right. Another thing is about some of these examples. From hello world till assembly math is what we want that you just go over it, or you should be able to understand. For example, how to write a simple contract, how to write increment decrement contract. You should be knowing about the primitive data types, how you can get the maximum of a data type by maximum and minimum depending on the recent Solidity version. You should know that you can use uint or uint 256 interchangeably, right? But when it comes to creating the Kitchak 256 hash, just don't use it uint. You will have to use like the whole data type name, which is uint 256, right? Then here we have fixed size array and dynamically sized array as well. So that's another thing. All the variables, like when we talk about this guys, these are stored on the blockchain, whereas these are stored in the memory, and then there are others which are just transient. So they are something which are just there during the execution of the transaction and they just get vanished after it, and we call it as transient storage, right? We'll be talking about transient storage also when we'll be doing some examples. You can also create the constants like this, and we have got immutable where you can initialize the value of a constant during the deployment. So there's a difference between constant. The value of constant needs to be there at the compile time, whereas immutables can be initialized during the deploy time, right? So immutable and constant cannot be initialized during the runtime. That's the reason they are called immutables and constant. If you want variables which should undergo changes during the runtime, then you cannot use constant or immutable. You will have to declare it without these keywords. This is known as reading from the state. This is known as writing to the state. Anything that you do with the state, and if it is changing the value, you will have to pay the gas. This transaction needs you to pay the gas. This transaction is free of cost, but you will have to use the visibility modifier, which we call it as view. If it is not reading from the state, it is just returning a random number that has nothing to do with the state, then you'll be using pure here. Okay, these are the keywords that we mostly used: ether and ether way and gway. So one ether is 10 to the power 18 way, and one ether is 1 billion gway. Billion has 9 zeros, and this is how you can declare this, guys. Either you say 1 into 10 to the power 9 or 1 gway is going to be the same value assigned to 1 gway. Same goes for 1 ether, and 1 way is just number 1. So gas is a unit of computation, the amount of gas spent that you spent in the transaction. And then the gas price is per gas unit, how much gas price you're going to pay. The gas price is specified in GWay, but you can like also calculate that in ether by converting GWay into ether. Then gas limit is how much gas you are willing to spend for particular transaction, and block gas limit is how much gas units can a block in Ethereum have, right? How much maximum amount of gas allowed in a block. And that is something which is set by the network. Ethereum has 30 million of gas limit, right? Polygon has I think 22 or maybe less. So it depends as on the configuration of the blockchain. So this is an example. It is going to throw an error because it will exceed the block gas limit. You can see it's a while loop that is never going to be timed out, right? So it will consume all of the gas. Should know this. Then of course, if else if else. This is a way of branching. This is another way of branching where you are using ternary operator. Sorry, we call it as the shorthand operator. And here question mark is what we call it as the ternary operator. And this is the shorthand way of writing the if else statements. And then for and while loop. So this is the for loop and this is the while loop. Mapping. Ethereum has a mapping, but you will not be able to get a list of keys, right? That's not how it is in Ethereum. You will have to have a different library that keeps track of the keys as well. So you will not be able to get the number of elements in a mapping. That's a limitation, but you will be able to get the value given the key. You will be able to set the value given the key, and then you will be able to remove an element if you have the key. So you need a key every time you want to operate the mapping. You can create a nested mapping as well. And then if you talk about array, there are several ways through which you can initialize an array. This is a fixed size array, and they are all publicly declared. Means it is going to occupy the storage on blockchain. It's a storage variable. Here, this array is initialized right during the compile time, and you can return an array. Make sure when you are returning an array type should always have the location specified, which is memory. Array can, if it's a dynamic array, you can use push to add element at the end, and also you can remove the last element by pop. Length of the array is possible. However, if you are going to remove an array from an index, it is not going to reduce the size. There will be a vacant location, so you will have to you know you will have to do a shift operation, because if you delete an array, it is not going to change the array length. It is just going to reset the value at that index. So if array was of type uint 256, deleting here is going to just reset the value, right? It is not going to shift. So you'll have to perform shifting operations explicitly. In memory, you can only create fixed size array. You cannot create dynamic size array. Here they are given example to remove array element by shifting elements from right to left. So if you want to remove an array at a given index, then the best way to do that is just replace the value of the last array index and the array index of interest, and you can then shift the arrays from right to left and then just remove the last element. So that is a good way, or that is the way which is widely used. You can also remove an array element by copying the last element into the place to remove, right? And then all you need is to just pop the last one. So this is also one of the used way. You can try out these examples if you want to. I'm not going to do that. Anom, these are mostly used when you want to show any state transitions. You're going to use this in the advanced NFT assignment. So you'll get an exposure on using Anom. This states which you are, or the statuses which I have selected, each of them are uint 8 numbers, and pending is 0 and 1 2 3 and 4. So cancelled is 4. So what you can do is, when it comes to set, you will have to pass a number, right? So whatever the serial number is based on this sequence, you can pass it. It's uint 8. So which means that if you want to create HAC 256 hash of this function signature, you cannot just say status. Status is of type enum, and enums are at the core uint 8. So you'll have to just say set uint 8 and then create the HAC 256. Cancel this way, or you can just pass number 4 here and then just assign that 4 to the status. So which means that the status can be typecasted to uint 8. So that is allowed. Typecasting of enum to uint 8 is allowed. Declaring and importing enum can be declared outside the contract, and you can just declare it like this, right? So this is a new concept in Solidity called user defined value types. So if you want to use duration instead of uint 64, you can do that. If you want to use the type called timestamp instead of uint 64, you can do that. These are all the user defined names, right? You can give your own name as well. Your contract is going to identify it as the underlying type is going to be the one which is written after is, but you can just alias it with your own names. You can see here. So these are all shift left operations, shift right operation, So what it does is it does logical OR of timestamp and this guy. That's going to give you the clock. These are the examples. So you don't need to get confused. This duration which you see here is of type UN64, but you are just aliasing. That's what is allowed in Solidity under user defined value types. Then we have got user defined data types, which we call it as the struct. So if you want to declare your own type called to do, this is how you can do. You can create an array. You can keep on pushing the values to the struct as well. Yeah, you can get based on the index, you will be able to get values as well from this to do's array and update any of the element given the index, right? Struct can be declared outside of the contract and you can just use it inside the contract. So data locations is one thing. Storage, memory, call data. So storage, whatever you declare here, they are all storage variables. This is storage variable. Memory is access from the function. So if you are declaring any variables inside function, then it is occupying the memory, right? Memory is not permanent. It will just stay during the execution of the transaction, and then every time you invoke a transaction, you will get a new memory. It is a data location. Call data is a data location from which you will be able to get all the function arguments. So if we talk about this example, if you want to get the arguments, then within the function you will have to access the call data, right? If you are using underscore ARR, you are actually accessing call data, which is the location where all the arguments of your functions are going to be there. There is another type of data location that came in recently. We call it as the transient storage. So we know about constant, immutable, etc. We know about the storage variable, etc. But we don't know about the transient storage. So transient storage is where the data is cleared out after a transaction, but the thin difference between memory and transient storage is the memory is actually cleared after a function call, which means the life cycle of memory is bracketed within the execution of a function, whereas this transient storage lifetime is bracketed during entire execution of a transaction, right? So if you check out my last week's office hours, I did an example of transient. So check out that. Then function. Okay, so I have been telling you to not, follow or I mean to not actually code along with me, but definitely when I say that, hey, the transient storage demonstration was done last week, just write a note so that after this session you can go back and just watch it out. Yeah, you can return outputs from a function, of course you know it, but here we are just talking about what are the different ways you can declare the return values, right? And you can also return the values directly. So if you declare it like this, you can assign those values and it will be returned. If this is returning like 3 values, you can grab it here. Say that it is returning you more values and you don't need to use, say, the one which is a second, and you can just you can just keep the second position, you can just left out the value there, right? You don't need to declare anything. So there is a limit, by the way, how many values you can return. Anybody knows how many number of arguments can return in a function? Anybody? It's okay if it is wrong. Yeah, you can return 8. Okay, let me get to the question. We are going to discuss about Uniswap V4. Yes, but these are all the prerequisites. I'm going to share with you the prerequisites. So next time when you come, I just want to make sure that you go over it. Usually We use array to keep track of mapping keys. Is there any other method? You can use a library, which is of course using, no, it's not using actually an array, but it is using a combination of, two mappings, where in one mapping, you are keeping the track of how many values does this mapping has, and then you are also keeping track of, yeah, basically you need to use like a combination. So there is a library available in Open Zeppelin that you can do it. I think it's enumerable mapping. You can just go and take a look. Nu means, so there is max of 256 nm, uint 8. Yes. So if you are declaring any values within nm, yeah, it cannot go beyond 256 because each is uint 8. For user defined value types, does it affect the Solidity code size? No, it will not, because underlying type is the one that is the the base type. Where do we watch the previous session? The previous session, I have actually started keeping that link handy with me. So let me get that for you. It's a Notion stuff.
Yeah, I think I got the link. Sorry, I just realized it. Is this session? Is this link?
Office hour recordings through in is what should be there. Yes, there.
Okay, take it.
All right. So I'll be just once I push all this material our on our GitHub, I'll just share a link with you so that you can take a look. This is all something which you all know, but I just want to make sure that you know it well. So you need to look till assembly math, where we are talking about the error, how to do loop, any variables in assembly, all this nitty gritties, bitwise operations, some of the ways of common guess optimization, signature verification, hashing, decoding, encoding ABI, libraries using try catch, importing, creating contracts from other contracts, and what are the side effects of the same, calling the contract function selector, delegate call, low level call, what is the use of fallback, when do we use the fallback. You all know this, so just make sure you're not surprised. What is payable, interface, and a contract difference, visibility. Right? So public, private, external, internal. What is the difference between view and pure? Inheritance, just get these things clear. Shadowed inheritance. What is a super? When you use super, what happens? You should know that. Constructor, events. So when you work on event subscription and event driven architecture, some of the best practices, function modifier, which we already talked, how you can, sorry, it's they are just a function modifier. We talked about function selector here. And errors can be using require, revert, assert. Now we also have a way to custom error, so make sure you know this. So that's not everything. You need to also look from Ether wallet to ERC1155, just this guys. And later on, you will have to look into the DeFi section as well till stable swap AMM. Yeah, so till here. So constant product, constant sum, depending on who wants to go over. Even if one of the student want to go over all this stuff, I will be going over all this stuff, but my intention is to start V4 as soon as possible, so I just want to make sure that you are knowing all these things. If any questions, you can just take a note, write it down, and then we can talk about the questions, or you can just keep on slacking me, so that when we meet next time, I'll come with the answers ready. So give me a few minutes after we end the meeting, and then I shall give you all these links in